So we have several different ways that we can classify matter, and that's what we're going to focus on in this video, is how we classify our materials. So the first classification we're going to look at is whether we say that something is a pure substance or a mixture. So a pure substance is a material or a substance that contains only one type of particle. A mixture is going to contain more than one type of particle. So it's going to contain two or more different types of particles in that substance. So an example of a pure substance would be water. Water is only made up of water particles. A mixture, a good example of a mixture would be something like salad dressing. Salad dressing has vinegar, oil, water, spices, all different types of particles in it. So a pure substance has only one type of particle. Mixture has two or more types. The next classification we're going to look at is compound and element. And so now we're focusing on the individual particles themselves. So an element is a particle that cannot be broken down any farther. It's made up of only that one thing. So an example of an element would be hydrogen or carbon. We have our periodic table of elements, and those are our most fundamental building blocks. And so our elements can't be broken down into smaller pieces. Our compounds can be broken down into smaller pieces. So compounds are going to be made up of more than one type of element. So it's similar to pure substance and mixture in the sense that a compound is going to be made up of two or more types of elements. And the key with compounds is that the two or more types of elements are going to actually be connected. They're going to be bonded together. Now, an element has only one type, and there is a type of element that is a little bit of an exception to this element rule, and that is called a diatomic element. So some of our elements are called diatomic, which means they're made up of two pieces, but they're the exact same thing. So a particle diagram for a diatomic element would look something like that. So it's still a purple circle, and it's two purple circles, but it's two of them stuck together. So since it's only one type, that makes it an element. A compound would be like an open circle, a closed circle, and an open circle. So it has two different types of particles or elements bonded together to make one bigger particle. So that's a compound. One more classification we have is homogeneous versus heterogeneous. And these are descriptions for our mixtures. So we can describe a homogeneous mixture as something that is spread uniformly through the material, and a heterogeneous mixture would be something that's not spread evenly. So something that clumps together, salad dressing would be an example, because when you let salad dressing sit, you'll see the different components separate out. So that is not a heterogeneous mixture. Milk is a good example of a homogeneous mixture because milk is actually made up of several different components, but it's so evenly mixed that we can't tell that it's made up of different components. To us, it just looks like one thing. So that's our example of homogeneous versus heterogeneous. So homogeneous is uniform, and heterogeneous is not uniform. So now let's look at some particle diagrams to identify some of these different things. So I have three examples here. In my first box, I need to decide if that is an element, compound, pure substance, or a mixture. So if I'm looking at this, the only thing I see are purple dots. And since the only thing that I see are purple dots, I'm going to say that this is pure. Now, I don't know if it's an element or a compound yet. The only thing I've determined is since it only contains purple dots, it's a pure substance. Now, if I look at each of those purple dots, it's only made up of one thing, that one purple dot, and that makes it an element. So this box would contain a pure element. If we look at our second box has green particles and blue particles. So since it has two different particles, that's going to make it a mixture. Now, we don't know if it's a mixture of two elements, a mixture of two compounds, or a mixture of elements and compounds. So that's what we're going to look at next. So if we look at our green dots are just made up of the one thing. So that's an element. So we know that our mixture has at least elements in it. So now if I look at my blue dots are still only made up of blue dots. So that falls under our category of diatomic elements. So it's still just an element because it only has that one type of material to make up that whole particle. So this is a mixture of elements. Finally, if we look at our last particle diagram, so I see two different types of particles. I see a particle where there's two green dots and a purple dot, and I see a type of particle where it's a pink dot and an orange dot. So that makes this a mixture. And now if I look at each of these individually, so my pink dot and orange dot, so that they're stuck together, they're made up of two different things, so that's a compound. And then my purple dot with two green dots is made up of two different things stuck together, so that's also a compound. So this is, our last box is a mixture of compounds. So the rules that we use to determine whether it was a pure substance or a mixture and an element or compounds are the same rules that we can follow if we wanted to draw these again. So if we asked for a drawing of a pure element, you'd look at this and go, okay, so if it's pure, there only has to be the one type of particle. And if it's an element, that means those particles need to only be one thing. So it can't be more than one symbol. So we can use those rules interchangeably to go back and forth between identifying particle diagrams and drawing particle diagrams.